Random walks are really very simple to code, but they're very, very interesting, particularly if you get into the art generated by random walks and exploring various colors, patterns by varying the number of blocks with each step and so on. So I've written a program that does these things, which we'll discover as we go along. So one of the things that this program does is it paints what I call a handy compass. So you can see the various directions. So this is east. So the question is, did this random walk go mostly east, mostly west, mostly north? Well, it looks like this one, of course, it's still running, but so far it's gone mostly northwest. And some other one that I would run might go mostly east, and so on. So it's kind of interesting to actually make a table for various runs and look at which directions they were predominantly. You could also get into even counting the steps in each direction, or almost endless experiments that you could design. Okay, before I forget to tell you, that crystal, that glass block there notes the origin. So from the time this started, it basically went more north and west and never went back to the south or east. Okay, let's look at another one. So to do that, we're going to move about 200 to the east. And now you can't see any of the things that I did before. And let's do a one with 300 steps. Each step is 3 blocks long, and we're going to use the block group 0, which is blue and TNT. That's fun because at the end we get to blow it up. Now this one is going southeast. When you look at east, south is to your right. Yep, now it's being drawn. The compass is being drawn. Notice that the compass is drawn while the random walk is taking place. And when we look at the code, I'll show you how that's done. So it takes a fair amount of time to draw the compass. So you wouldn't really want to wait for it to draw before you ran your random walk. So what this does is it does it at the same time, which is called synchronously in a programming world. Okay, so one thing to do here is where do we want to blow this up? So which TNT would be best to strike? But before we get to blowing it up, let's see, from the origin, which is that glass brick right there, it went mostly west and south. Although it did from the beginning start out east, but then it wound up going mostly west. Just shows you can't ever really know what a random walk is going to do. So let's get out here in the kind of the middle where all that TNT is. And of course I'm going to need a flint and steel. Okay, there it goes. Yay. I particularly like these patterns. And of course, one thing to wonder is there any gaps where it actually can't get to the rest of the pattern? But looks like that has actually rarely happened because they're random. So there's enough dynamite mixed in to blow up the entire world. Okay, let's move again. We're going to move 200 to the east. And this time we're going to run, let's do this on a white canvas. So Another one little utility I have here is called Canvas. And when you run Canvas, it actually draws you a white canvas. Now it draws it by quarters, so meaning that it starts out drawing the quarter to your, if you're facing east, it draws the quarter to your left, then to the upper left, then the upper right, and then the lower quadrants. But look, I don't see them. Where are they? Well, they're really there. In fact, if we click one, see that it is white there, but I'm not really seeing them. So let's go up here, and what we have to do is force Minecraft to repaint this world. And I usually can, there, see, it did it. So now let's get to where we're kind of balanced, so I can see some horizon everywhere, you know, roughly the same. We'll go back down here, then we will implement. We'll do another random walk, which will be 300 steps. We're going to go one step at a time, really, so that's really tight, and we're going to use the second pattern. And that's what I call my black and white world, my black world. So now, see, most of the blocks are some shade or color with black, and we're only taking one step at a time. So this one may get completely filled in, or it might leave an empty space somewhere, which would end up being white. And of course, we can't blow this one up, unfortunately. I've thought about putting dynamite under all of them. But anyway, that just shows my nature of liking to blow things up. We're going to look at the code for what makes all this happen. It's pretty straightforward. And you'll be able to get the code using the link on the blog, MakeCode.com. Okay, now we seem to be going mostly west. We started out going a little bit south, but now we're definitely going west. And I think we have gone as far as we are going to go. At first glance, the random walk code may appear complicated and long, but it's really not if you break it down into steps, which we're going to do. The first step is to look at the parameters or arguments. The two words mean the same thing. We have three arguments: steps, step size, and block group. Steps is the number of steps in the random walk. Step size is the number of blocks in each step. And block group specifies which of the block groups, the colorful one, the black, more or less black and white one, or the blue and TNT one, which is my special favorite. So the first thing I always do when on the chat command to run a program is to say that the program is running. Why would I do that? Well, it's easy enough to forget to press this block, and sometimes I turn it off to remember that I want the program to run. So when I get over to my Minecraft world and I say run and nothing happens, or is it happening? Well, it's good to have had a message which tells me indeed it is running. Next step is to check the parameters for validity and to set to some default value if they're not. So steps must be if steps is less than 1, that's out of range, or if it's greater than 3,000, that's out of range. So we would set the steps, we would give a message and then set the steps to 100, which now becomes the default. And that means that if you omit the steps variable, which of course means you have to omit step size and block group, then the default value is 100. The next one is to check step size, which must be between 1 and 10. and otherwise we're going to set it to 3 after giving the message. The next step is to check block group, and block group must be between 0 and 2, otherwise it's out of range, and we're going to set it to 1. Okay, so that's now what would happen if we just say run without specifying any of these variables? Well, if you look at the code, steps would be set to 100, step size to 3, and block group to 0. So the program will run using its defaults. That makes it very convenient. Okay, at this point we know in the code we know that the parameters are valid. So we're going to take a few more steps before we get down to the guts of the code, which is the loop for the random walk. We are going to call a function called go-to-ground. And I will show you go-to-ground at another time. All it does is wherever the player is in the world, no matter how high, it will cause that player to be on the ground. And because we assume that this is a flat world, then we know the player will be at world coordinate 4. The X and Z coordinates will be whatever the player was at after running go to ground. Next, we want to set the position where the player is to the player world position. And since we know the player is on the ground, the Y coordinate in the world is 4. And then we want to run, actually it's more like launch Handy Compass. Handy Compass prints the directions of east, south, north, and west in the sky, so that after the code runs you can see which direction the walk went, more or less. So by running it as a chat command, it actually launches it, and it continues running asynchronously. That means it runs effectively at the same time as the following code. And I do that because Handy Compass, this thing is very slow because it has its print commands, and you wouldn't want to, if I had this as a function, if I ran a function called Handy Compass, it would run synchronously, which means it would wait until the code has finished before it would go on to run the rest of the program. So running it asynchronously is the thing to do. Now then, next thing I want to do is I want to place a glass block at the origin, and just at position 2, which is actually I'd rather have it at 3, just above the player's head. Oops, I'm sorry, that is, oh, I'm sorry, that was correct because I have it at position is the player world position, and if I add 2 to that, the player is at Y position 4, and this would make it be 6 because I'm adding 2 to the Y coordinate. And this block is there because I want later, after the random walk, which kind of goes all over the place, every direction possibly, I want to be able to look at it and find where it started. So by placing this glass block sort of in the sky, then I'll be able to easily locate the origin. And this walk is going to be done with a builder. It's fun to also do it with the agent, but by doing it with the builder, it's a great deal faster than doing it with the agent. The agent one is cute, but not very efficient. That was a comparison of algorithms. Okay, but moving right along. We're first going to teleport the builder to this position, which was the player world position. We're going, now the interesting thing about remembering position is that during this code running, I can move the player to wherever I want to be. For example, I might want to zoom way up and move around to actually watch the random walk taking place. And this would only work if I had, we couldn't use relative coordinates and do that because the relative coordinates would always be relative to the player. Okay, we want to move the builder down by 1, which means that would be the top layer of the ground, which means it's level with the grass. And that's because we want the random walk blocks to be placed to replace the grass effectively rather than stand up. Now, we're going to then teleport the player up 20 blocks so that the player has a better view. And of course, you can still move the player around to anywhere you want it, as I described before. Now, next comes the great big loop. And this is the loop, you can see it going down, 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 down. This is the loop that is the guts of the program. It repeats steps time. Well, that's the number of steps. So for each step, this loop is going to pick a block, turn, place step-sized blocks, and then do it again. So the first thing we want to do is pick a random number from either 0 or 1. So this code does exactly that. We're then, and this is actually picking the direction of the turn, either left or right. And we need to know that before we pick the block, and I'll explain that in a minute. So now we want to choose the block based on the block group argument. So this if statement has an if, an else if, and an else, because the block group can be 1, 2, or the else covers the case where it is 0. So if the block group is 1, then we're going to pick a block randomly from the dual array. And the dual array is the colorful array of blocks. Well, let's just go look at the dual array. There it is. So when the program started, there were 2 arrays defined, the dual array and the black array. And these are simply arrays of blocks that I have chosen, and I call them my jewel array just because it kind of reminds me of jewels. The black array is shades or various colors of black. So then so here I pick from the jewel array, I pick a random member of it, and it would be from 0 to length of the jewel array minus 1. Why wouldn't it be the length of the jewel array? Well, if the length is 6, then that would include 0. So we would want to choose from 0 to 5. So that's why we have minus 1. And next, if the block group is 2, we want to pick from the black array using the same method. Then in the last case where the block group is 0, we want to pick either a blue or a dynamite block based on which way we're going to turn. So if the random number which we picked above is 0, that means we're going to turn right and we're going to get a blue block. But if it's left, we're going to pick a TNT block. Yay. Then the next thing we do after picking a block is we do the turn. If the random number is 0, we're going to have the builder turn right, and if it's 1, we'll have the builder turn left. Then we'll have the builder place a mark, and we're going to have the builder move forward step-size steps, which would be that number of blocks, and then have the builder trace the path from where you placed the mark up to this position. And we're going to trace the path with a block. And then we're going to say done. Well, why do I want to do that? Well, it's sometimes hard to know when a program is finished, particularly if it involves a loop, and particularly if you're not putting out messages like I am here. So I always like to have, I like to know when it starts running at a minimum, when it starts, and then I like to know when it ends. So that's the code. Now let's look at another example. Let's move over to another place. And let's create a canvas. Oh, and look, it actually painted the whole thing. That's nice. And then let's run 1,000 steps, which is actually my favorite. I've run 3,000, but that really, I think I'll run 3,000. Why not? Run 3,000 and how I think maybe 2 blocks per step. Oh, 3. Go for 3. And let's use that beautiful jewel pattern, group of blocks. There we go. So you know what I did? I didn't say run. I just started entering the parameters. Getting a little ahead of myself there. Okay, so now there it goes. Oh boy, this is going to be fun to watch 3,000 steps. See if oh, there's our west, east, and plus Z is south. Boy, this one is really traveling south. The origin is right there. You can see the little. So will it go off of our canvas? That's cool. Okay, I'm going to let this run so you can see it, but oh, I crashed into the ground. Okay, don't do that. Okay, I'm going to let this run, but I will say goodbye, and I hope you'll read the blog, and there are several suggestions for how to modify the code for it to do something else wonderful. Bye, and remember, we code, make code. sitting here thinking about if I made this with TNT, I could really have fun. This is running like all over the world.